Hi all, welcome once again back to Edumonk. We are currently running with our Geography UPSC syllabus. We have already completed the solar system, then continent building, then different types of mountains building, then plate boundaries, plate tectonics theory, continental drift theory, everything. Now we are moving to our next topic, interior of our Earth. The total length of to our Earth's surface to Earth interior is around 6370 kilometer. 6370 kilometers. Then we can classify our Earth interior to three categories. First one is crust, second one is mantle, and third one is core. Then there will be a question arises: how we will study about the interior of Earth? We already said that we have three kind of layers: crust, mantle, and core. Then the length to Earth interior is a huge or a big kilometer. Then how we can study what is inside the Earth interior? For the studying the Earth interior, we are choosing two kind of sources. First one is direct sources. Direct sources and indirect sources. Okay, for the direct sources, we are using the surface rocks. Surface rocks. Second one is volcanoes. Third one is mining projects. Fourth one is drilling projects. Then fifth one is deep ocean drilling projects, and sixth one is integrated ocean drilling process. These are the direct source of study. Then we are moving it to indirect sources. For that, the first one is temperature and pressure variation. Then second one is seismic activities. Third one is meteorites. We have discussed about what is meteorite and meteorites in the our I think it's in the our first session. If you want to know more about meteorites, please watch our first session of geography classes. Then fourth one is gravitation, and fifth one is magnetic field. These are the direct and indirect sources for our Earth study. We can directly drill into around 6,370 kilometers inside our Earth. So we are using different sources to study, to understand what is inside our Earth. Then first of all, we can go into our first layer, that is crust. Crust is the outermost layer of Earth. Crust is the outermost layer of crust. It's an outermost layer of our Earth. The thickness of crust is varies under oceanic and continental areas. In continental areas, the thickness of crust is high, and in oceanic areas, thickness of crust is low. Then the continental crust is thicker area. While we are looking into the Himalayan regions, the thickness of the crust is around 70 to 100 kilometers. So we can write in ocean regions, thickness of crust is less. In continental region, thickness is high. Then Himalayan region, thickness is around 70 to 100 kilometers. That's a huge thickness. While we are taking an example, sometimes the oceanic crust is thinner than around 5 to 30 kilometers, but sometimes the continental crust is around 50 to 70 kilometer thick. That's a difference. Then while using the temperature, while considering the temperature of crust will increases with depth. We have a surface around 50 to 100 kilometers crust. When the depth increases, the temperature of earth interior also increases. That means nearer to the mantle, the temperature of crust is around 200 degrees Celsius to 400 degree Celsius. If the crust, if the earth surface which lies in a high region or high crusty region, the temperature of earth interior which increases about 30 degrees Celsius per kilometer. If the higher region of the crust, the temperature rises up to 30 degrees Celsius for every kilometer. Then the crust outer, then the crust's outer layer is made up of sedimentary rocks. By beneath of that, there should be sedimentary, there would be metamorphic rocks, igneous rocks, and also crystalline rocks. Then we are moving to mantle. Before that, there are many most abundant element in our earth crust, that is oxygen, abundant elements in earth crust. First one is oxygen, second one is silicon, third is aluminum, fourth one is iron, fifth one is calcium, and sixth one is sodium. These are the most abundant element in our earth crust. If you are looking at the highest percentage is oxygen, 46.6%. Then it's followed by silicon around 27.7%. Then aluminum around 8.1%, iron 5%, calcium 3.6%, and sodium just 2.8%. Then we are moving to our next layer, that is mantle. Then by looking to mantle, this is the center portion of our earth. The mantle, the mantle lies between around 35 kilometer to 2,900 kilometer. It equates to roughly around 83 percentage of Earth total volume and 67 percentage of total mass. Then the upper portion of mantle is called as portion of mantle is called as asthenosphere, which is the plastic layer where the plate movements happens. Then the density of mantle varies between around 3.3 to 5.5 5.5. Then also the mantle is mainly composed of silicate materials. In crust we have seen Cl, silica and aluminum. In mantle we can see Sima, silica and magnesium. In core we can see Nife, that means nickel and iron. These kind of materials are mainly composed in each particular layers. In crust you will get the higher composition of silicon and aluminum. Then mantle you will get higher composition of silicon and magnesium. Then core you will get higher composition of iron and nickel. Then we can move to the final or last layer, core. This core is made up of or made up of heavy materials. Sometimes it's called as nickel layer, that is nickel and iron. The major composition is carried out by the nickel and iron. The core is around 2,900 to 637 kilometer. The core is in between the outer core and inner core. In each layer there is different continuities are there. We can look into that. Then like this is the first one, the crust, mantle and core. It is the simplest form of diversion. Then we are going to a much complex division of interior of Earth. We can divide Earth's interior into two kinds. First one is this is the mechanical layer of our Earth. Mechanical layer of our Earth. This is the physical layer of the Earth. Physical layer. While studying, you have to consider these two figures consecutively. Then you have to study. In the mechanical layer, left side you will given by the distance. In this here you are given by the distance. In physical layer, 0 to 30 kilometer, up to 0 kilometer means it's a mean sea level. Okay, 0 to 30 kilometer you will have outer crust. Then 30 kilometer to 60 kilometer you have inner crust. 60 kilometers to 450 kilometers you have upper mantle. 450 to 2400 kilometer you have lower mantle. 2400 to 5150 kilometer you have outer core, and 5150 kilometer to 6370 kilometer you have inner core. The total distance from surface of Earth to interior of Earth is 6370 kilometer. While considering it's a mechanical layer, 0 to 100 kilometer, it's lithosphere. Then 100 to 400 kilometer you have asthenosphere. 400 to 2700 kilometer it is mesosphere. 2700 kilometers to 2900 kilometers it's D layer. 2,900 kilometers to 5,150 kilometers. It is outer core. 5150 kilometer to 6370 kilometer. It is inner core. Then we are going with the uh, physical layer of Earth. In between outer crust and inner crust, that means in 30 kilometer, here is a discontinuity that is known as Conard discontinuity. Then in between inner crust and upper mantle, there is also a discontinuity that's known as Mohorovic discontinuity. Then in between upper mantle and lower mantle, there is also a discontinuity that's known as Rapeti. Then in between lower mantle and outer core, there is also a discontinuity that's known as Gutenberg discontinuity. Then final in between outer core and inner core, there is also a discontinuity that is known as Lehmann discontinuity. These are the discontinuities which is in the physical layer of our Earth. Then by analyzing the complete physical layer and mechanical layers, you can see in the mechanical layer you can see the lithosphere. It is 0 kilometer to 100 kilometers. Here in the physical layer you can see the outer crust, inner crust, upper mantle. These all are the part of our lithosphere. Then the asthenosphere is in between 100 kilometers to 400 kilometers. Here you can see it is between upper mantle and lower mantle. So you can say that asthenosphere which lies in between upper mantle and lower mantle, or which is the part of mantle. Then 400 to 2700 kilometers, there is mesosphere. Here it's a part of upper mantle, lower mantle and outer core. Then you can see the D-layer structure, then outer core and inner core. Then while considering the mechanical layer, you have to understand what is the condition, or is it a solid, liquid or gaseous stage inside the Earth. If you have to see the lithosphere, it is solid and brittle. That we already told. The continents or the lands are solid and brittle particle which is fragmented and move towards different parts through the plate movement. Then we are going to the asthenosphere. It is a plastic layer. The solid and brittle landmass or continental parts are moving above the plastic asthenosphere. Then mesosphere, it's solid and brittle again. Then D layer is again plastic layer. Then outer core is liquid. This is very, very important. You have to understand the outer core is liquid. Then the inner core is solid. These are the condition or composition of the interior of Earth. Lithosphere is solid and brittle, asthenosphere is plastic, mesosphere is solid and brittle, D layer is plastic, outer core is liquid and inner core is solid. I think everyone understand this concept. If you completely understand the concept of the interior of Earth, you can easily understand the earthquake and volcanism. Then we are moving to another topic, volcanism. Then we can move into detail into volcanism. Here is a part of volcanism. The magma is coming out from the earth. Then the liquid or the material which is coming out from the earth is known as ejected matter. Ejected matter can be classified into three. It contains magma, gases, and pyroclast. Ejected matter contains magma, gases, and pyroclast. This magma can be classified into two: acidic magma and basic magma. This magma can be classified into two: acidic magma and basic magma. In these gases, which includes 70% of water vapor. 70% of water vapor. Then pyroclast means it is the solid and fragmented particles. So, as the part of volcanism, there are some ejected matter which includes magma, gases, and pyroclast. The magma, which can be classified into two: acidic magma and basic magma. Then, what are the specialties of this acidic magma? We can move on to that. Considering the acidic magma, it contains more silica. Acidic magma, there should be more silica. Then that means there is more viscosity. More viscosity. More viscosity. So more viscosity, that magma travels or flows less area. Less area. Then it contains more silica, more, so that it have more viscosity, so it travels less area. Most of the cases which will solidify interior of earth. Mostly solidify interior of earth. But in the basic magma, which contains less silica, so it have less viscosity, so it travels or flows more. So most of the cases it solidify on the surface of earth. Mostly solidify on the surface of earth. That means then here there is an inverse relation. If the magma contains more silica, there should be less iron. That means silica inversely proportional to iron. Remember this. So the acidic magma contains more silica, less iron, and the basic magma contains less silica and more iron content. This is the difference between acidic magma and basic magma. Then I think you have understand this. Then we can move to gases. These gases, it contains 70% of water vapor. That means most portion of the gases is contains the water vapor. Then pyroblast is the solid and fragmental particles. That means dust. We can say it's a kind of dust or some small particles. These pyroblast can be classified into four. First one is volcanic ash. Volcanic ash. Volcanic ash means these are, before that we have to understand one term, volcanic dust. Volcanic dust is the finest particles. Then volcanic ash means these are smaller, bigger than the volcanic dust, but these are the kind of fragmental particles. Then third one is lapillae. Lapillae means it's a p-shaped pyroclast. P-shaped means p-shaped pyroclast. Then fourth one is tuffs. Tuffs means these are water saturated pyroclast. Okay. Then we have already discussed the ejected matter, magma, gases, and pyroclast. Difference between acidic and basic magma, pyroclast. And in pyroclast, there are four kinds of pyroclasts are present. First one is volcanic ash, second one is volcanic dust, third one is lapillae, and fourth one is tuffs. Then we can move to the balance topic like type of volcanism or classification of volcanoes. The volcanoes can be classified into three based on three things. First thing is on the basis of intensity of eruption. On the basis of intensity of eruption, volcanoes can be classified. Second thing is basis of nature of eruption. Then third one is on the basis of location of magma eruption. So here the volcanoes can be classified into three based on three conditions. First thing is the intensity of eruption, and second thing is the nature of eruption. Third thing is the location of magma eruption. So first of all, we are talking about the intensity of eruption. So as considering the intensity of eruption, the volcanoes can be classified into three. First one is active volcano. Second one is dormant volcano. Third one is extinct volcano. Active volcano, dormant volcano, and extinct volcano. Then first one is active volcano. The name itself says the volcanoes which are actively eject magmatic and other materials are called the active volcano. They are still ejecting magma. That's known as active volcanoes. For example, we can say that Mount Stromboli in Italy. We can say that. Then we are moving to dormant volcano. These are the volcanoes which are erupted in the past and likely to erupt in the future. These are erupted in past and likely to erupt in future, but no present eruption. Example, we can say that Mount Vesuvius, Mount Vesuvius in Italy. Then extinct volcano means the volcanoes which were active in the past and not likely to be active again. That means dead volcanoes, dead volcanoes, which are these extinct volcanoes which are active in the past time and not likely to be active again. This is known as dead volcanoes. Uh, Example, we can say Mount Kilimanjaro. It is in Africa. So, by considering basis of frequency and intensity of eruption, the volcanoes can be classified into three: active volcano, dormant volcano, and extinct volcano. Active volcano means the volcano still ejecting magma. For example, it's Mount Stromboli from Italy. Then the dormant volcano. These are the mountains which are erupted in the past are likely to erupt in the future. Example, Mount Vesuvius, Italy. Then extinct volcano. These are dead volcanoes which are not likely to active again. This, for example, it's Kilimanjaro, which is in Africa. Then on the second condition, first condition we have completed. Second thing is on the basis of nature of eruption. On the basis of nature of eruption, the then on the basis of nature of eruption, the volcanoes can be classified to two. First one is explosive volcanoes and quiet volcanoes. Explosive volcanoes means these are the volcanoes which which eject explosive materials with a loud sound. Ejection with loud explosion. Ejection with loud explosion. That's known as explosive volcanoes. Then quiet volcanoes means which erupt or eject magma without any explosion. Without any explosion. These are known as quiet. Then, as a part of nature of eruption, volcanoes can be classified into explosive volcanoes and quiet volcanoes. In explosive, the ejection with a loud explosion, and quiet, eruption of magma without any kind of explosion. Then we are moving to the third thing, that is the location of magma eruption. It's a quite interesting thing and a little bigger one than based on the location of magma eruption. You can say on the basis of location of magma eruption, the volcanoes can be classified into two. First one is intrusive volcanoes and extrusive volcanoes. Intrusive volcanoes and extrusive volcanoes. Intrusive means the magma solidified inside the earth. Magma solidified inside earth. That is known as intrusive volcano, and extrusive means magma solidified outside earth. We already discussed there is acidic and basic magma. If acidic magma, there is more silica, more viscosity, which travel less. So most of the cases, the acidic magma solidified inside earth. So in the intrusive volcano, there is acidic magma, presence of acidic magma, and the extrusive volcano, there should be presence of basic magma. Basic magma. Then first of all, we can talk about the intrusive volcanoes. Intrusive volcano, we can again classify into two things. First thing is massive, and second one is tabular. Then massive means huge mass deposition. Tabular means smaller mass deposition. Then, for example, in the massive volcano, you may heard about batholith. Batholith means a huge mass of lava deposited inside the earth or under the surface of earth. That is known as batholith. Then in the tabular or smallest deposition, again, which can be classified into two, concordant and discordant. Concordant and discordant. In concordance, the magma is solidified in horizontal way. Magma solidified in horizontal way, and discordant means magma solidified in vertical way. This is known as discordant. For example, we can say something like that. First one is sill. You may heard about sill. Sill means the horizontal solidification of magma. Horizontal solidification of magma. Then dike. This is the vertical solidification of magma. Vertical solidification of magma. Then laccolith. This is dome-shaped solidification. Dome-shaped solidification. Then you can see balance here. Then lopolith. Lopolith means cup-shaped, cup and saucer-shaped, or saucer-shaped, or cup-shaped. Saucer-shaped solidification. And last one is phacolith. That is wave-shaped solidification of magma. So we have completed the intrusive volcanoes. That means as a basis of location of magma eruption, the volcanoes can be classified into two, intrusive volcanoes and an extrusive volcano. In intrusive, which can be classified again into two, massive volcanoes and tabular volcanoes. Massive means it's kind of huge mass. For example, for that is batholith. Then tabular or smaller deposit magma deposition, it can be again classified into concordant and discordant. Concordant means the horizontal solidification, and the discordant means the vertical solidification. For example, for that we have told about sill, dike, laccolith, lopolith, and phacolith. Then we are moving to the extrusive volcano. We have completed the intrusive volcano. Then here's the volcanism. Then extrusive volcanoes. The extrusive volcanoes we can classify it again into two. First one is fissure type, then central type. Central type. Extrusive volcano again classified into two, fissure type and central type. In the fissure type, first of all we can complete the fissure type. Fissure type means the magma eject through small fissures, not mountains. There are small fissures in the soil. So through the small fissures, magma get randomly ejected out. That is known as fissure type volcanoes. If you take some examples, in South Africa, the Ethiopian highlands. Sorry, Borborema in South Africa. Then Ethiopian highland in Africa. Then there is another example is our Indian Deccan Plateau. It's also a fissure type volcano. The main advantage or main feature of this area is these areas will contains the black soil, as the Deccan Plateau black soil, which is one of the best kind of soil mainly used for growing cotton, or which is abundant for the cotton industry. So most of the fissure type of volcano, we can see that area with contains black soil. Then we are moving to the central type volcanoes. Central type volcanoes. The central type volcanoes, we are classified it into four types. Central type. First one is Hawaiian. Second one is Strombolian. Then Vesuvian. And fourth one is Pelian. Pelian. Okay. From here to here, the intensity increases. Okay, we can move to the first volcano, that is Hawaiian. Hawaiian means is known as smoking mountains. Smoking mountains. Here is the continuous ejection of magma happens. Continuous ejection happens. So the continuous ejection means there is no blockage in the fissures or the pipes which magma coming out from the earth. We know that there is two kind of magma, acidic magma and basic magma. Acidic magma solidifies very fastly, and basic magma solidifies it will take time to solidify. So there is a continuous ejection of magma, so that there is no blockage in this kind of pipes. So we can tell us this is basic magma, and which is least intense. Then we can move to Strombolian. Strombolian means it's a which increase which is here its intensity is higher than the Hawaiian. So this slightly stronger volcano. Most of the cases the magma trapped in pipes. So we can tell us this is acidic volcanoes. This is acidic volcanoes. Then this Mount Stromboli is called as lighthouse of Mediterranean Sea, because most of the cases this Mount Stromboli uh, are eject magma, so that a presence of light is there, which always give navigation for the ships which is passing through the Mediterranean Sea. Then we are moving to the third mountain kind of volcano, that is Vesuvian. Here you can see, you will see the ejection of pyroclast and more gaseous content. We already told there are three kind of ejection materials. First one is magma, second one is gaseous matter, third one is pyroclast. In Vesuvius, there are more pyroclast and more gaseous kind of material. At the time of ejection, the water vapor which is ejected out to the atmosphere, and this water vapors contains sand which forms rains in this particular area. That's a major feature of these Vesuvian kind of volcanoes, so that the rain is formed. So there should be the formation of water saturated pyroclast. Water saturated pyroclast means tuffs. Water saturated pyroclast means tuffs. Then the final volcano is Pelian type. Pelian is most intense volcanoes. It has a strong activity. Here the pyroclast is developed is higher, and most of the cases which will develop the formation of glowing cloud. Here you can see the cone blast. Cone blast means it's a volcanic mountain, magma coming out through this pipe, and this is an acidic magma, so that it very fastly solidified, which will makes a crater here. In this crater, by over the time, the debris water which are deposited here, by the time of magma ejection, very fastly this cone will blown off. That's known as cone blast. This is the usual thing in the Pelian kind of volcanoes. For example, we can say that Mount Krakatoa, Mount Martinique. These are Pelian kind of volcanoes. Then we can move to next topic, earthquake. Earthquake is a shaking of the surface of Earth, resulting in the sudden release of energy in the Earth lithosphere that creates seismic waves. So earthquake, it's a sudden shaking of Earth, which release energy. Next keyword. Then this produces seismic waves. So, an earthquake can be defined as it's a shaking of surface of the earth resulting from the sudden release of energy in the earth lithosphere that creates seismic waves. This earthquake may be due to faulting, then plate movements, then boundary changes. Anything can be happens there. Then we have to understand three terms in the earthquake. First one is focus. focus. This focus is the point where the faulting begins. Focus is the point where faulting begins. That's known as focus or hypocenter. Focus or hypocenter. Then that's the origination point of earthquake. Then second term is epicenter. Epicenter is the point which is directly above the focus. Directly above the focus. That is known as epicenter. That means the intensity of earthquake is highest in this epicenter. Intensity is highest in this epicenter. Okay, then earthquake focal point epicenter. In this figure, we can tell us this may be the focus of an earthquake. The epicenter should be this place. So maximum intensity of the earthquake will happen in this region. From here, the seismic wave passes through different directions. Then we can move to what are the seismic waves. What are the seismic waves? Before that, how these kind of earthquake make changes on the earth's surface? Okay, we have already discussed about what is earthquake, how it is formed. These are formed too. It can be due to the plate movements or folding, faulting, or boundary changes. Anything, it will lead to earthquake, and as a part of that, it should release the energy. We know earth, this is the earth surface, which is a closely packed thing, closely packed, and it have different kinds of layer, crust, mantle, and core. Most of the cases this kind of earthquake can be happen in the mantle or crust area. In this area there are different kind of rocks, different kind of rocks. This earth is completely closely or finely packed. When the energy releases, the seismic waves passes through rocks. Seismic wave, these are rocks. Seismic waves passes through rocks. This rock will shrink. The rocks will shrink. So it will make changes on earth surface. Then after passing of the wave, this rock return to its original position. Return to original position. Okay, here the seismic waves which are passed through the rocks, when it passed through the rocks, the rock will shrink, which changes the complete earth structure. Then after the seismic wave pass through the rocks will retain its original position. It makes shaking on earth surface. Then what are these seismic waves? What are the seismic waves? Seismic waves can be classified into mainly into two. First one is body waves. Second one is surface waves. These are seismic waves, body waves, and surface waves. These body waves again classified into two: primary waves and secondary waves. Primary waves are these to be first recorded in seismograph. These are fastest moving. Then it have a velocity of 6 to 7 kilometer per second. These are called as compressional waves. Then it affects the volume of rocks. These are the major features of P waves. Then S waves, and these P waves passes through all media. Then the S waves, these are secondary waves which have velocity less than P waves. Then these are distortional waves. And also the S wave disappeared in liquid medium. That means this travels only through solid medium. Here you have to understand one concept. I will show you. This is the interior of Earth: solid inner core, liquid outer core, and this is the epicenter, and the waves are generated from this point. Then the waves are passing in different direction. Here you can say we have a liquid outer core. In the liquid outer core, S waves will not pass through the liquid medium. P waves only pass through the liquid medium. So the S waves move from different direction, but it will not enter to the liquid core. So here you can say in this medium, P waves only passes through it and comes to another direction or another side. The S waves only moves to its own direction only. Here you can see two areas. First one is P wave shadow zone and S wave shadow zone. The shadow zone means this is area which the impact of earthquake will not affect. Area where impact of earthquake does not affect. This is known as shadow zone. Here P wave has a smaller shadow zone in two sides, but S wave has a large shadow zone. It's due to the liquid outer core, because S waves does not passes through the liquid medium. We have already completed the interior of Earth. There we were told about different kind of layers: the solid brittle layer, then plastic layer, liquid layer, everything. If you have any kind of doubt, please see that video about which explains about interior of Earth. Then these are the body waves. Body waves are P waves and S waves. So S wave shadow zone is higher, P waves shadow zone is lesser. Then we are moving to the surface waves. Surface waves, it can be classified into two. First one is love waves. Second one is Rayleigh waves. love waves and layer waves. These love waves are the first kind of surface waves, and this is the fastest surface wave. Okay, it's a fastest surface wave. It moves from side to side, or otherwise we can say this, it moves like a wavy structure or snake kite kind of pattern. This wave is known as love waves. Then we are moving to Rayleigh waves. These are vertical waves. These are vertical waves. Here it also form a wavy kind of structure, but it's more vertical. Then these kind of Rayleigh waves which form, which will leads to tsunami. Tsunami. The tsunamis are formed due to the Rayleigh waves. Then there are different kinds of earthquake are there. It can be natural earthquake or volcanic earthquake, tectonic or isostatic or plutonic or artificial earthquakes. These will completely create a shaking on earth, and it will changes the physiographic features which both done by the nature and man-made. Here while considering the wave distribution of earthquake, you can see most of the earthquakes which are happening in the circum Pacific ring belt, and also the Mediterranean and Himalayan region. This is due to plate tectonics. Plate tectonics or converging or diverging boundaries. These are the major reasons for the earthquakes. Then if you consider the highest earthquake prone zones in India, its first one is Himalayan region. We know that the Indian plate and Eurasian plate, the convergence which will leads to earthquake in this region. We know that the nearest country of India, Nepal, it is highly prone to this kind of earthquake. Then instead of that, the Northeast India, Western India, Northern Punjab, Haryana, Uttar Pradesh, Delhi, and parts of Gujarat belong to the highest and high risk categories of zone, which neighbors it's zone 5 and zone 4 and zone 5. Okay, this is about the topic earthquake. We can discuss the other topics in next video. Once again, thank you all. If you have any kind of doubt, you can ask questions in our Telegram channel. This Telegram channel's links are provided in the description of this video and also this channel. Once again, thank you all. Before that, we can see some questions, previous year questions. In this first question, you can see explain the different layers of earth interior and their characteristics. We have already discussed. You can draw the two diagrams about mechanical layer and physical layer, and you can explain. That will give you full marks. Then second question is discuss the distribution of earthquake and volcanoes across the world, how they are related to plate tectonics. We have already discussed what is plate tectonic theory. Then we have discussed about the converging and diverging boundaries. You can write it easily and take full marks. Then third one is how do seismic waves help you understanding earth interior. we have explained about P and S wave. Then we have also discussed the diagram which shows shadow zone. You can draw that diagram and explain this answer very effectively and take full marks. Then fourth question, it is asked in 2020. Explain the formation of fold mountains with example. We have already discussed what are fold mountains, how they are formed, then where you can see the fold mountains and block mountains. Everything we have discussed in the class. You can uh, easily understand. I think you may easily understand this concept, and you can write the answer very easily without any hesitation. Then I will give you one more chance here. You can write or draft the answer for these kind of questions, and you can send me through the telegram. I will correct it and definitely give you feedback about that. Okay, thank you all. Thank you very much.